Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha. May God be pleased with her online college live lesson, A-level maths year 2. We're working through the chapter on differentiation, and we're going to take a look at sin x and cos x, differentiating sin x and cos x, but we're adding on an extra bit, which is the chain rule. So let's begin. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Chain rule is named after a chain, and if you think of a chain, it starts with one part of the chain that immediately links to a second part of the chain. So it's that first part linking to the second part that you have to try to remember with the chain rule. So let's take a look at what we mean. We've got something like, suppose we have to differentiate something like sine of 3x. Yesterday we learned that sine x or theta, but let's use x today. If I've got something like sine x, then that can differentiate very easily to cos x. So now how do we apply that? Because that only works when you've got x after the sine, and that will end up with cos x. But this time we don't have x alone, we have 3x. That's a bit more complicated. So what the chain rule says is that first differentiate as normal, that's your first link. And then the second link is you take what's slightly different, you differentiate that, and then you multiply with what your answer was with the first differentiation that you did. So the first part is differentiate as normal, even though it's a bit more complicated than you're used to. And then the second part is take the slightly complicated bit, the slightly different bit, and differentiate that as well. That's the differentiate the second bit, the complicated bit. And with your two answers, you just times them together. Okay, let's see how that works. So sine 3x. If I differentiate that as normal, then that's going to become cos 3x. So the first step is just like normal. If sine x differentiates to cos x, then you would expect sine 3x to be no different. And in the first step, sine of 3x differentiates to cos of 3x. But now we have to do the second part of the chain, which says differentiate that bit that was slightly different. So the bit that was slightly different was that here we had just normal x, but here we've got 3x. So we need to differentiate that extra bit that was different. So 3x differentiates to just 3. So I can differentiate the first bit as cos 3x, but the second bit, the 3x, differentiates to 3. And all we're going to do is times the 3 onto the answer that I had from the beginning bit. So just keep that beginning bit separate. That was cos 3x. And now that gets, all of that gets times by 3. So the final answer would be just bringing the 3 to the front, 3 times cos 3x. 3 times cos 3x. Okay, let's try a couple of these to see if you can try and get the pattern and know what is the first part and what is the second part. To help you understand what is the first part and what is the second part, we normally work from an outside in principle. So what you start with as your first part of the differentiation is what's on the outside. So what's on the outside is a sine of something. So you need to just differentiate normally the sine of something. And then once you've done that, then you go inwards and you say, right, what was that extra bit that was different to your normal textbook example that you'd learnt about sine? Well, you'd learnt sine of x, but on the inside here, we don't have just x, we have 3x. So then that tells you where to look next for the second part of the chain. Okay, so let's try this. Okay, let's suppose we have y is equal to sine of x squared. Sine of x squared. So the first thing I want to do is remember what does sine differentiate to? So just in the corner here, I remember that sine x differentiates to cos x. And then I look back and I say, well, that's very similar. It's sine of something. So I just used the first part of the chain as differentiate as normal. So that becomes dy by dx is equal to, and then because sine differentiates to cos, then this would be equal to cos. That's the only thing that changes. It's from sine, it changes to cos. We keep the x squared as normal. And then we take a closer look. So it's outside in. We've done the outside. Now let's take a look at the inside and we say, right, the x squared is not quite the same as your textbook example of sine x. So I need to take a closer look at x squared and I also need to differentiate that. So x squared differentiates to 2x. So I now need to times by 2x. Where did the 2x come from? I looked at x squared and differentiated that. That became 2x. So your total answer is, you can bring the 2x to the front. So I've got 2x times cos of x squared as my answer. So hopefully not too difficult for you. Let's try one more. So this one here, let's go with cos this time. Y is equal to cos of 2x plus 1. So straight away seeing the cos, I remember my first thing that I learned in my first lesson about sine and cos, which is that cos x differentiates to minus sine x. So just keep that in the back of your mind. And now you're looking at this and you're thinking, well, this is very similar. It's cos of something. So that's going to differentiate to cos differentiates to minus sine. So similarly, this is going to differentiate to minus sine. So I'll have minus sine. And then you copy the rest of it as normal, 2x plus 1. And then you go back to the chain and you think, right, the chain's not finished yet. There's a second part to the chain. I need to take a closer look and take a look at this 2x plus 1. What would that differentiate to? So 2x plus 1, 2x would differentiate to 2, and the 1 is a constant, so that disappears. So you just end up with a times 2. So times by 2x plus 1 differentiates to 2. So times by 2. Then bring the 2 to the front and you end up with dy by dx is equal to minus 2 sine 2x plus 1. Okay, notice how it was outside in, starting with the outside function, which was the cos function. Differentiate that minus sine, keep everything else as normal. And then the second step times by whatever that differentiates to. So you might ask, well, what if I apply that to what I learned yesterday, which is y equals sine x? What if I'm just differentiating that? So you can apply that, the chain rule principle, but you just wouldn't because it would just take too long. This is not needed, but just in case you want to see that it does work here. So sine is the first thing that we see. So sine x would differentiate to cos x, and then you can take a closer look at what's inside the sine function, which is x. Differentiate that, and that's just 1. X is 1x. 1x differentiates to 1. So you would just times by 1. And timesing by 1 doesn't really have an effect. So that's why it just is easier to write it as cos x and stop there. Okay, join me again for more differentiation tomorrow. Assalamu alaikum wa rahmatullah. Peace be with you and the mercy and blessings of God.